Hey guys, it's me, Julia. In this video, I'll be going over practice test number 6, calculator section, question 12. So let's get started. So, in 1919, H.S. Reed and R.H. Holland published a paper on the growth of sunflowers. Included in the paper were the table and graph above, which show the height, h, in centimeters of a sunflower T days after the sunflower begins to grow. So, here on the y-axis, we can see the height. Here on the x-axis, we can see the time. And this corresponds to this, and this corresponds to this. It's pretty clear, nice and simple. This question will be a slope question, and you'll know why. So the question is, over which of the following time periods is the average growth rate of the sunflower least? So the average growth rate refers to the slope because you want to know the rate, the rate of change, right? And if you don't know the rate of change, it's how much something changes over something. And it's usually time, and you take the change in y and change in y over change in x, and that will show you how much it changes over 10 seconds, 5 seconds, a second. And you can do the really complicated work technically, but there's just too much to calculate, and plus it's not a linear, so it's going to be pretty hard. But just thinking in really like simply by you can interpret this data and you can take advantage of this table. Actually, it's asking for when it's the least, when it's not changing that much. So we can see how these ones jump 18, you want to change 30, and then the 30, 30, 30, 30, 30, 30, 30, and you can see that right here, right? But then if you look at this part, it's only changing by 3 or 1, as opposed to it changing by 30 around the first like 2/3 of the data. So from here, we already know that it's going to be towards the around the 50th to 80th day. But then another way to confirm it is when you look at the graph, you can see how the slope is changing by very little, meaning the height doesn't change as much across time. So that's what the rate of change is showing, right? y2 minus y1 over x2 minus x1. It's showing the change in height over the change in time. And that's very, very, very low, right? So we can't even see the change here on the graph when the time is a lot. I mean, each interval is a lot, right? And it happens to change by 7 every time. So across 7 days, it's changing only by a little bit. Whereas for these 7 days, it's changing by this much. So we know the difference, right? Same 7 days, but only a little bit. Same 7 days, but a lot. So from this, we can just eliminate the rest, 0 to 21. So these 21 days, it's growing by this much. So no, that's a lot. 21 to 42. So it's changing by that much and changing by this much. So yeah, that's a lot. So no. Next, 42 to 63. it's changing by that much, and it's changing by this much. That's a lot. Well, we're left with D, which is going to be the answer, 63 to 84. It's changing by this much, the same 21 days. And it's only changing by like this much. So if you look at the vertical lines that I just drew right now, you can see how the intervals, the last interval has the least average growth rate. So D is going to be your answer.